Hello everyone. Welcome to the Teaching Computational Thinking workshop. Just as you can see, there is a section off to the right there for questions and answers. So anytime during the presentation, if you have a comment or a question, Rob or I will try and answer it as best we can. If not, we've got some time at the end of the presentation for some dedicated Q&A time, about 10-15 minutes or so. So, like I said, thanks for coming to the workshop. My name is Adriana O'Brien, and I'm joined by Rob Morris. We'll be going through the workshop here in just a second. So just to give an overview of the workshop, what we're going to be doing is we split it up into a couple of different sections. I'm just going to go briefly over and talk about what does computational thinking mean. I want to make sure that we're all on the same page and have the same working definition. I'm going to give a brief intro into the Wolfram language. Then Rob and I will be passing back and forth, walking you through a couple of classroom examples. And then also going into some specific generalized functionality. We're going to be working with Cloud Deploy, showing how you can incorporate that into your classroom. And then Rob's going to talk a little bit about incorporating social media into a variety of different classes. So the definition of computational thinking that I'm going to be working off of is one that states computational thinking involves solving problems, designing systems, and understanding human behavior by drawing on the concepts fundamental to computer science. So this is something that we've seen throughout the last couple of years, and it's really making a push, as can be seen by ISTE and the CSTA computer science standard. And I've got some links in here. Obviously you can't click on them right now, but later on the presentation and the notebook will be made available afterwards. So you can go through this, click on any links that are shown here. In addition to the ISTE and CSTA computer science standards, we also have the AP computer science principles that have made a really big push in supporting data-driven discoveries and trying to bring in computational thinking supported by programming into the mainstream curriculum. Just as a side note, we have given a previous workshop on computational thinking in the classroom. It's a little bit different than you'll find here. I go through a couple of different other classroom examples, but like I said, there's a link in the presentation here that you can explore after the presentation. So I'm going to go ahead and pass it off to Rob here, who's going to talk a little bit about the Wolfram language.
Hi everyone. Again, welcome to the workshop. So I want to talk about why the Wolfram language is useful for computational thinking. There are a lot of options out there, so why should we use the Wolfram language? First off, I've been using it for many years now, and it has gotten progressively easier and easier to use. In the beginning, it felt like a programming language, but now it's something that professionals and educators and students can just pick right up, natural language input, and we'll talk a lot about how to use that today. Not only is it easy to use, but it's something that your students can start with young, and they can use it all the way through, grad school and work. I've got a PhD using Mathematica. It's very easy to put into professional situations. In the classroom environment specifically, one thing I like about the Wolfram language is it's based on the notebook environment. So you can have data, you can have graphics, animations, text, you can have everything right in one place. And I think it makes it the ideal environment for doing lab reports or different types of assignments, or you can assign handouts using it that are more than just Word documents or something. Finally, most of you are familiar with Mathematica, and now we're calling it the Wolfram language, so you might be wondering what the difference is. Well, the difference is that it's no longer just Mathematica. It's everywhere. We have desktop clients, we have cloud clients. The Wolfram language is ubiquitous now. And so students can interact with it at school, they can take it home and interact through the web. All of their work can live in the cloud. So it's not just like having Mathematica sessions like it used to be. Okay, so we want to give you some specific examples of how to use the Wolfram language in the classroom. I'm going to talk a little bit about using it in the chemistry classroom, and Adriana is going to talk about the history classroom, and we're going to highlight specifically how to stay in line with the computational thinking paradigm. So let's talk about chemistry. It's kind of cheating, you might say, to talk about computational thinking in the science classroom. It's already very amenable to computational thinking. You're working with data, you're doing analyses, you're doing mathematical modeling. But I want to talk about not just doing a simple experiment, putting in the data, and doing a simple model fit. We can do a lot more than that. And I want to talk about why the Wolfram language specifically is good for that. So the Wolfram language, one of its great strengths is it has tons and tons of publicly available curated data that is built right in. So chemical data is a good example of this. Chemical data has thousands and thousands of chemicals that it knows about, and it knows things like space-filling molecular plots or atomic structure diagrams. It has physical info like the molar masses or the densities. I want to show you how you can pull these properties over groups of chemicals so that you can work with properties of groups and look at those. And even if you're not using the Wolfram language in, say, Mathematica or something like that, Wolfram Alpha has a ton of stuff that it knows about too, and your students can check that out for free. So one of the things that I wanted to show you is, well, first, you can use Wolfram Alpha right in the Wolfram language, which is great. But if you go to the web and you look up, you do a Wolfram Alpha search for, say, aluminum plus O2 goes to Al2O3. What you'll get is, enable this, what you'll get is a Wolfram Alpha page that will interpret what you asked for. I want to mix aluminum and oxygen, and I want to make aluminum oxide. It will balance the equation for you, tell you all the structures, give you all the names, give you lots of interesting properties about the reaction and the reactants. One of the things I want to highlight, something we offer, is the step-by-step solution on how to balance the equation. So not only did this tell you what the balance equation is, but you can go through and your students can learn how to balance the equation, which is something I think is just incredibly useful. So let's get to an actual lesson. I call this lesson Data Mining Chemical Properties. What we're going to do is we're going to look at chemical data for single chemicals, and then we're going to look for groups of chemicals. We're going to get properties of those chemicals, and then we're going to start looking for correlations among those properties, and then we'll try to fit those correlations. So the first thing I want to do is just get a list of all the chemicals that the Wolfram language knows about. So I already did that here, and there are many, as you can see. There are about 44,000 chemicals that chemical data knows about. So we don't want to work with all of those today. It's a little overwhelming. For now, let's just pick one in particular. So let's say that I want to know the molar mass of methylamine. This orange box is something that you may not be familiar with. It signifies an entity, which is kind of a newer thing for the Wolfram language, but they're very powerful to use. So if you want to get something like this, what you would do is type in chemical data, bracket, and then you want to get comfortable with control equals. That will open up a natural language box, and you can put in whatever you want. Methylamine. And then you hit enter, and it will figure out that you meant methylamine, and then you can look for the molar mass. I can do tab to autocomplete that. So that's how these entity boxes or the natural language boxes work. So I run this. I can get, it's going to update from the web. It's going to get the molar mass. And then I can also get all of the properties that it might know about for methylamine. So here are all of the properties it may or may not have information for. I say may or may not have because not all of these things are measured or publicly available for all 44,000 chemicals. So you may run into a situation where it returns missing, not available. That's something that you want to be aware of when you're dealing with the pulling in data with Wolfram Language. So first thing I want to do is I want to look at, instead of just the single chemicals, I want to take all of the chemicals and then I want to find anyone whose common name ends in acid. And that will give me a list of all of the known acids. Then once I find all the acids, then I can, for instance, find all of their densities and sort them and plot them to get a sense of all the densities of the acids. You can see here there's about 600 densities that it knows about, and they range between 100 and 5,000 kilograms per cubic meter. That's on itself, that's kind of interesting, but it's more interesting when you compare that with other properties. So here, I want to look at the density and the boiling point together, and I want to see if there's a correlation between density and boiling point. If there were a correlation, I would expect to see some structure in the data, but as you can see, it's not very structured. So there's probably not a strong correlation between density and boiling point. You could go through and look for different correlations by taking all of those different properties and pairing them off, but that's not very computational thinking. So instead what we're going to do is we're going to have the computer do the hard work for us. And what I'm going to do is make a list of properties that I'm interested in. For brevity, I've just picked about 5. I'm going to get all of those properties for all the acids, and then I'm going to have the Wolfram language pair all those properties up and plot them so I can just look through all the plots. It's kind of small to see here, but this is density versus boiling point. This is density versus the speed of light through the material. These are interesting plots. There's some structure, but they look kind of strange. There's one that stands out, though, as maybe having a simple correlation, and that's boiling point versus melting point. You can see kind of a upward linear trend here. So I'm going to take this data set, I'm going to plot it again, and I'm going to fit a linear model to that data set. So here I've used find fit on that data set. I've fit it to an mx plus b kind of model. It gives me the parameters. And now I can take and plot all those together. So just to recap, you can use the Wolfram language to pull down tons of publicly available curated data, and you can use computational learning methods to sift through that data and look for correlations and trends, and never have to measure these things in the lab if you don't want to. So I'm going to pass it back to Adriana, and she's going to talk about history.
Hi everyone. I'm going to talk a little bit about the history example. So taking a look at the Wolfram language, which you can find both in the cloud and in Mathematica, there's all sorts of built-in information within the Wolfram language. Rob already touched upon the real-world entities, so the natural language box, which he did, control equals, and he typed in a chemical. So that's available with our natural language input. There's all sorts of relevant information beyond that. We've got socioeconomic data, we've got historical figures. In addition to that, we just added in version 10 lots of geographic computation and financial data. And I'll be using some of these things in the history example I'm about to show. For my lesson, I'm going to be investigating the U.S. economy during the Vietnam War. So for this lesson, what we're going to do, and it's a very short, very condensed version of it, so obviously you can take this, and expand upon it in multiple different directions. But specifically here, choose a couple of major battles or offensives in the Vietnam War. I'm going to use the Dow Jones Industrial Average to signify what's happening in the U.S. economy at that time. So I'm going to be taking a look at the closing prices around the time of the battle, and then see if there's any conclusions that can be drawn after analyzing both the battles and then looking at the Dow Jones at that time. So like I said, there's all sorts of built-in information into the Wolfram language itself. Just like Rob said, in order to get those orange boxes, you just hit Control equals, and then for my purposes, you can see that this historical event is in the Wolfram language already. So I can take a look at finding the date. So here's the interval that we have for the Vietnam War. It's really nice and easy to make timeline plots. So for this one, we're going to make a timeline plot of the interval that was returned to us for the Vietnam War. So again, just click anywhere, press Shift Enter, and I've got a nice timeline for the Vietnam War. Now for this example, and for the time given, I'm only going to be taking a look at 3 different battles, sort of the beginning, middle, and end. So I'm going to be taking a look at the Battle of Ap Ba on January 2nd, 62, and then the Battle of A Drong Valley, and then the fall of Saigon. So obviously there are many more, but again, for our purposes, just taking a look at a few and seeing if there's any correlation or connections between battles and the Dow Jones. So like I said, there's a variety of different ways to generalize the state of the economy. I'm going to be using the Dow Jones, and what's really nice is that the Wolfram language actually has that information already built in, so I can connect to our servers and get the Dow Jones information from November 61 to March 62. Again, I'm looking at around the time of the battle, which is January 2nd, 1962. So you can see it change from my natural language input into this nice date object. So I'm going to create a dateless plot of the Dow Jones performance around the time of the battle. And I'm also going to include a notation to highlight the date of the battle. You can see that by this epilogue here. It's going to be a red line at the time of the battle. So again, the blue line signifies the Dow Jones performance, and then just glancing at the information looks right about at the time of that battle that it took a steep dive down. But let's go ahead and take a look at the 2 remaining battles. Basically going to repeat the same sort of process for both the Battle of the A Drong Valley and then the fall of Saigon. So for the second battle, it spanned. It had a start and an end date, so it's a little bit, the code looks a little bit different with my notation. So using the epilogue option here, I'm going to have a red line at the start date and then also at the end date. So let's take a look at the Dow Jones here. And again, plotting from September 1965 to January 1966. And the red line signify the start and the end of this battle. For the fall of Saigon, Wednesday, April 30th, 1975. I'm going to go ahead and again go out to our server and pull in the Dow Jones information from March 75 to July 75 and make a nice plot here. Again, using dateless plot, here is the financial information, and then the epilogue is the thing that draws the line. So drew it at April 30th from 0 to the max, so 0 to the max here. So in your classroom, and it's spread out a little bit, but taking a look at all the plots together, it's really a nice computational thinking activity where you have the data in front of you, encouraging your students to say, can you make a connection here? Is it possible to say that, yes, you know, some of these battles had a direct effect on the economy? Obviously, there are lots of different variables that come into play here, but it prompts that discussion. It allows you to have that data-driven, you know, flow to a history class. So questions like, you know, is there really a connection between these major offensives in the U.S. economy? Is the Dow Jones a good representative for measuring the state of the U.S. economy? Are there other factors that could come into play, and then sort of repeat that process by looking at the Dow Jones or looking at some other index, and then perhaps incorporating other aspects to the history classroom? So those were the two examples, classroom examples, where you can easily see that computational thinking approach supported by programming in the Wolfram language can really get into a wide variety of classrooms. You know, it's really good at math, physics, and now we showed chemistry and history here. What we're going to do now is I'm going to talk a little bit about some newer functionality with working with Cloud Deploy and then specifically form function. This isn't classroom specific, and it's not an activity that fits into one subject or another. It's just putting it out there that you can have students or you yourself create, you know, very easily create these web forms. So what we've done is we've built another sort of super function where it's really easy to build online interfaces as a beginner programmer in the Wolfram language. For students, I've noticed this, you know, from middle school to high school, you know, that accomplishment of, oh, I created this website, I created it and I can share it with others. It's a really nice way to introduce you know, the web form development. So I'm going to go through 3 examples here, and then just walk you through how you could create a web form. So let me go ahead and show, this is something that I created, or that we created with a middle school classroom. This is a form that is created in the Wolfram language. They were creating energy efficient homes, and so we wanted to have the students actually create this and self-analyze and self-reflect to see, you know, is my house really an energy efficient home? So this is a nice example of creating a quiz or a survey type form. It links to a data drop where everything's connected. If you're not familiar with data drop, oh man, I could go on for a long time, but there's lots of information out there on data drop. I know that we've given some workshops as well. It's basically a nice collector for storing information off of these web forms. So like I said, really nice example of how to create a survey or a quiz using the Wolfram language. Display built-in data. So here's a very basic web form. What it'll do is it'll take any city and a date range and display the demographic data for that years. As you'll notice, there's this red spiky off to the right. This indicates a Wolfram Smart Field. So it's expecting a city, and it only took, you know, one little parameter more to specify that it's looking for a city. So if I type in something else, if I try to type in cheetah or a number, it'll automatically give me an error message saying that, nope, you need to enter in a city. So it's really nice and easy to use that smart field. You don't have to really do anything else, do any extra coding to have that smart field enabled. So here, let's take a look at what that looks like. So I'm using New York City, very basic, and it displays the population for the years 2000 to 2010. You can also develop tools for the classroom. So let's take a look at it there. So maybe in your classroom, maybe in your math class, you want the students to not only be able to plot using technology, but then they can also create their own web form that does that as well. So here I've got smart fields, so it's expecting a mathematical expression. So I can type in any sort of function, and it's going to go from -5 to 5. And here's my nice result. So again, a couple of different ways to utilize form functions and cloud deploy in the classroom. You yourself could create these, or you could have your students create them. Like I said, it's not a huge amount of code, and there's lots of examples out there to use. So I wanted to go through just a very basic how to create a Wikipedia word cloud generator. So here's the code. I'm going to take an article from Wikipedia. I'm going to take the frog article. I'm going to delete stop words, so things like the, and then I'm going to create a word cloud off of that. So that's the code that you would use in order to generate the word cloud. Here we go. Lovely. So what I'm going to do now is put it into a form function. So this is what you can see as, okay, it's going to take a subject for my Wikipedia article, and then there's a title of the form, and then I've got a description. You notice in here that I'm going to generate the result as an image. So this is what it looks like basically. Oh yeah, here we go. Oop, forgot a little something. Here we go. Okay, so it's a wiki word cloud generator. So this is what the form is going to look like when I put it out on the cloud. And it's going to have an input field for me to type something in, the article title, and then that subject, that article is going to be sent to the Wikipedia data, delete the stop words, and then generate a cloud. Okay, so let's actually take a look at using cloud deploy. You notice I just copy-pasted this form function into the cloud deploy. A little extra code that I added, my cloud actually names the cloud object. This is really useful because if you don't name it, it's going to generate a new link every time I run this code. So if you're like me and change your code, you know, once, twice, 3 times, 4 times, and again, you'll want it to rewrite. You'll want it to write over what was there previously, or else you end up with a lot of forms in your cloud directory. So I've named my cloud object. I've set the permissions to public, which means that anyone can view this link. So I'm going to go ahead and click on it. Let's see here. Okay, lovely. So let's make a word cloud of some dolphins. Ta-da! So again, really easy, not a lot of code that's involved, and you get sort of a lot of bang for your buck. So again, going from the code that I would use in my Mathematica notebook, utilizing form function, and there's a lot of information in the documentation as well. I know we had a question previously about the hash sign. That's used for pure functions, and we can get back to that here in a little bit, but basically you've got using pure functions here that whatever the form was submitted at subject, you know, place it here in this function, and then using cloud deploy to actually send it out online and setting permissions to public so that anyone can view it. What I'm going to do now is I'm going to hand it over to Rob, and he's going to talk a little bit about how to integrate social media into your classroom. Oh, wait, before that, sorry. Before that, I did want to mention that if you wanted to get started right away and you don't have a Mathematica license, you can go to the Wolfram Development Platform and get started for free. So again, this link is in the notebook, and this is the link to get started.
All right, guys. So we've talked about using academic-style data to, to do some computation on chemistry and history, but students sometimes get bored with academic-style data and they need to have their lives spiced up a little. So I want to show you how you can do something that's relevant to their lives and they don't realize that they're doing actual computation. They think they're just having fun. What we're going to do is integrate some social media data into our lesson plans. You can do this for a lot of different classrooms, anything where you have a computational approach in mind and you're looking for some data to use. There's a lot of social media data out there that is amenable to lots of different lessons. So I'm going to look specifically at Instagram data. I have picked a user at random. Hopefully it's none of you guys. And so I get their ID. Instagram labels every user with a numerical ID. This username is Brimble. You can see that Brimble has uploaded 380 pictures as of the writing of this notebook. They have about 390 people that they follow, and they're followed by about 356. So I'm going to take this user and I'm going to pull in all of the picture IDs that this user has uploaded. So again, Instagram has numerical IDs for every picture. I'm going to pull in those IDs. That will be the data set with the basis of it. Just to give you a sense of what I'm talking about here, these are 5 of the actual pictures that I've gone ahead and downloaded. So each picture has some information associated with it. Like I said, it has its numeric ID. What we're going to work with today is the latitude and longitude. So almost every picture has the location data available. There are a few that do not. Sometimes there are names of places. By looking at these, Trondheim, Bergen, looks like these pictures are in Norway. So let's find out. Let's grab the longitudes and the latitudes for these pictures. And to do that, I'm just going to use replace. So you see here that the latitude and the longitudes are given as replacement rules. So I'm going to just replace over the data set, and I'm going to delete anything that's missing. And then I'm going to use GeoListPlot to plot all of the latitudes and longitudes. So here are red dots on all the places where those pictures were taken. Does seem like Brimble spends a lot of time in Norway. But Brimble also gets out a little, does a little traveling. You can start asking computational questions already. One thing that I want to know is, did this user spend a lot of time here and then say make one round trip around Northern Europe? Or do they spend some time here, go out and take a trip, come back, spend some more time, go out and take a trip and come back? So having your students ask these questions and then challenging them to quantify those questions is really at the heart of computational thinking. So how are we going to quantify that question? Well, what I'm going to do is each picture I know they're already sorted by their timestamp. So I know that they're already in order of when they were uploaded. And I'm going to pair each picture off with its neighbor, and I'm going to find the geographical distance using geodistance. I'm going to find the geoposition of each picture and then find the geographical distance between each successive pair of pictures. And then the distance, I'm plotting it in miles here, the distance will tell you the distance between two uploads. So between the first and the second picture that Brimble uploaded, there were about 200 miles. And then there were 100 miles between the second and third picture. There was about 1.5 miles between the third and the fourth. So by looking at these data points, you can get a sense of, are the subsequent pictures geographically dispersed, or are they located near each other? Well, it's not very computational thinking to just look at the graph. We have tools for that. So we'll construct a histogram. We find that most of the pictures, by far, were taken within 50 miles of each other. And that makes sense. Most people take more than one picture at a time in the same place, and so it makes sense that most pictures are coupled geographically. But there are instances of pictures where they're separated by 3 or 4 or 500 miles. Questions that you can challenge your students with are, why do you expect to see this shape? Is this shape common? Is it a known distribution if you're doing statistics? Is this a typical user? Could you look at other users and do the same thing and figure out whether or not this person has certain types of travel habits that are peculiar or they are typical? Having exercises like these makes students do math and do computation without thinking about it. Their questions come naturally, and they want to build the computational tools around them rather than going the other way. So I'm going to pass back to Adriana.
Thanks for holding on there while we're figuring that out. So I just wanted to touch on teaching in the cloud. In the last year or so, we've made available an online interface for utilizing Wolfram Alpha. And what's really nice is that you can do all of these lessons in the cloud. You can generate web forms. You can pull in real-world data. You can, analyze certain situations. What I found, especially in the academic space, is that it's you might find older computers. I've been to several middle schools and high schools that, they're dealing with an older version. But with the cloud, that doesn't matter. Because with the cloud-based platform, it's really the strength of your internet connection, because all the computation is being done on our end, on our servers. So it really doesn't matter the strength of your computer, just really of your internet connection. And by teaching in the cloud, not only do you get to do, a variety of interesting things, like, you can create web forms, you can access them. In addition to that, you can make math and science fun by using interesting data sources, just like Rob had shown with the social media data. So that wraps up our workshop. Thanks for attending our Teaching Computational Thinking in the Classroom. We hope you got some really nice ideas about how to incorporate Wolfram Language into your classrooms. I know we only showed chemistry and history, but in previous workshops, like that Computational Thinking in the Classroom, I talked about how to integrate into a biology and English classroom. In addition to that, Rob and I will actually be releasing some blog posts here in the next, 2 weeks or so, and we'll be touching on how to bring Wolfram Language into a wide variety of classrooms. So not only we'll have the math class, physics, history, and English class. And so you'll get that really nice wide variety of how can I bring computational thinking and programming into these courses. We did make the notebook available for download, and then you'll also get a link. I believe it'll be in the resources, so you can play around with some of these things. Yes. And so what we'd like to do is open up the Q&A to ask any questions. So if you do, let me make this a little bit bigger here. we can go ahead and answer some things. The location of the blog, it's basically, let me go here. So, blog.wolfram.com. This is where all of our blogs will go, like I said, in the next 2 weeks or so. Where are the older presentations found? Sure. So if I go to Wolfram main site, you'll see up at the top there's a support and learning tab. And if I go to video and screencasts and then go to channels, that kind of segments things off nicely. There is an education channel, but the specific ones that I mentioned are in virtual events. So if I scroll down a little bit, you'll see the computational thinking in the classroom. And then previously we had some Wolfram Language for STEM education a year or two ago. So there are some nice resources here in the Wolfram screencast and video gallery. Okay, so here is, oh, there's a history here. Oh, event history, some nice ones that you can take a look at. Oh, and I did mention the Wolfram data drop briefly about that's where you could store your data from web forms. So that'll be a really nice resource if you're at all interested in utilizing the Wolfram data drop. Let me just show you the datadrop.wolframcloud.com. Has all sorts of information. You can send information to a data bin, which is basically a collector, via email, web form, Twitter, the Raspberry Pi, you can use that. So lots of information here on how to get started with data drop and connecting to web forms. We've got one here. Do you have a workshop for secondary ed teachers that need to start to create lesson plans and units with use of the Wolfram platform? Now that's a really good question. We do have, let me show, the Wolfram Community is a really nice place to get started if you have questions about how to program, or if you want to share some resources. This is where I go when I create my workshop material for the middle school or the high schools. This is where I post it. And then obviously if you just can't get that thing to work, we have all sorts of professionals that are on here monitoring the site if you want to post something. Okay, I've got a question here that we can discuss. Does viewing a cloud deploy project require the user to download a plugin as a user would with CDF document? That's an excellent question. No, it does not. Everything that's deployed as a cloud object, well, most things that you deploy as a cloud object, everything I've shown, like the web forms, etc., nobody needs nothing to view it. You don't need a plugin, you don't need anything special, you don't need a license. As long as you set the permissions to public, anybody can view that link. So those are web forms. You can cloud deploy instant APIs. You can deploy, so if you're familiar at all with the demonstrations project and how that requires a plugin to interact with those materials, we are getting to the point where you can deploy interactive manipulates, and and you can interact with those without a plugin. That's a really good question. Our school used Chromebooks, so downloading software, that's another really good reason why to use a cloud platform. So Rob and I had been using the desktop product, which would require a plugin. But if I go to the Wolfram development platform, I'm just in a browser, so I'm just going to go ahead and log in. And you'll see that I can just start programming online. There's nothing that I needed to download, and this is what you would want to use if you're using Chromebooks. So again, in the browser, nothing fancy, but I am using Wolfram Language in order to evaluate this. So we've got a question here from Daniel. Where do you get the sources, like the chemistry information? The best place to see where we get our information is actually on Wolfram Alpha, because we're required to list all of our resources there. So if I go to Wolfram Alpha and I type in, mineral something, down at the very, very, very bottom, there'll be a spot that elaborates on what the sources were used for getting at that information. And it's basically the same for in the Wolfram Alpha, or in the Wolfram language that you find in Mathematica. So the primary source is the Wolfram Alpha knowledge base. So we have a huge, just enormous team of Wolfram Alpha data curators, and that's all that they do. They go out searching for information, making sure that it's correct, double, triple checking their information, and then putting it into our knowledge base. There is some external sources here. So we've listed off all any and all data sources that we used in compiling this information. So that's a good question, but anytime you have a question about, where did you get this information, how can I get at the sources, I would use the Wolfram Alpha website, and then you can scroll down to the bottom and it should give you the resources there. We've got a question here from Steve about how does Mathematica work on the Raspberry Pi? And that's a really good question. So if any of you are familiar with the Raspberry Pi device, it's basically a credit card-sized computer, basically. You hook in your mouse, your keyboard, your monitor, and you're good to go. Especially with the Raspberry Pi 2 device, Mathematica is just screaming fast. It works so well. I mean, it's actually scary fast how well it works. So basically, when you run the Raspberry Pi, when you boot it up, you'll see these two icons here on your screen, and it's just as if you were, working on your regular device, on your laptop or on your computer. I double-click on this, and boom, I've got my Mathematica notebook. Now, obviously, because the Raspberry Pi is not as powerful as most desktops or laptops, there is some lagginess with the very heavy computation powers, but like I said, with the Raspberry Pi 2, you're going to see a huge increase in performance with the graphics rendering and some of the other things. Another really nice feature with the Raspberry Pi is that it's got that GPIO interface, or that connection. So with the Raspberry Pi, and you hook up a breadboard, you can do all sorts of things with the Raspberry Pi in Mathematica. So for instance, let me scroll down here and you can see some of the examples. Building a GPS tracker with the Raspberry Pi, snapping pictures with the Raspberry Pi. So you can directly connect to the input-output on your breadboard and actually control things on there. I've done some very, very basic things on the Raspberry Pi with Mathematica, especially in the middle school, elementary school area where we coded it so that when you pressed a button, it made a LED light go on and on. But it's a really nice interface to programming, especially for a younger student, because versus a command line, the notebook interface is like a document. I can put headers, I can put text around it that explains what's happening. So it's a really nice interface for interacting with sensors and other things like that for the Raspberry Pi. Okay, let's see if we've got some other questions here. We had a question from Robert. I think perhaps you're asking, what is the best way to get started with faculty that are easily intimidated by this type of platform? And that's something that and we're almost out of time, but we'll go ahead and continue the Q&A just for a couple more minutes here. Is that, it's just one more thing for teachers to learn. It's just that, they're already, especially in the secondary space where it's just, it's one more thing to learn. We are, here in the next little bit, we have something in the works called the Wolfram Programming Lab that will have all sorts of pre-built activities, very simple. It walks you through step by step on how to do something interesting. And so hopefully with that type of content that's already developed, we're looking at seeing, can we push it into those classrooms that you don't normally see programming? Can we get it into the English classes? Can we get it into the history classes? And that's another reason why we, worked at creating this workshop, is that with, you wouldn't really think about having programming in a history class. We really wanted to showcase that, with just, even with natural language, I mean, I didn't even have to do any programming syntax to get the historical Dow Jones information. I just typed in Dow Jones from September blah to, November blah. I just typed it in. There wasn't any special syntax. So with the natural language input, with the Wolfram Alpha connection, we're really going to try and push and develop content so that educators can see how easy it is to get started with the Wolfram language. Okay, everyone, we're going to go ahead and close this session right now, but we're going to move over to the chat room. So we're going to go ahead and do that. So again, thank you so much for attending, and if you have any other questions, Rob and I will meet you over in the chat room. Thanks.